Okay guys, the first worksheet I want to talk to you about today is this system substitution worksheet. This is the one I was telling you about yesterday because I accidentally did the days out of order. This has become not necessary for us because we already did several substitution problems yesterday. There's no need for us to do a whole entire other worksheet. So then why am I giving it to you? Well, number one, I already had it copied. Okay, and I don't want to just throw it away as wasteful. So I'm giving it to you to do as extra credit if you wish. Okay, any questions? Okay, this is one of my favorite worksheets that we ever do. And you remember how sometimes, well, I'll get there in a second. The parachutist called from her cell phone. Hey, Walter, you'll never guess where I am. I'm parachuting down over your neighborhood. Even though I'm descending at a constant rate of 4.8 feet per second, I'm afraid my landing will be a little rough. So do me a favor, go outside and get on your roof. When you see me pass overhead, throw me a pillow. Okay? There's so many things wrong with that. So this clearly is one of the worksheets that we're doing that we have to suspend our belief, right? Or suspend our disbelief. Because really? And it gets better. Okay? It does. It gets better, all right? So clearly we're just focusing on the math here and we're having fun with the problem. Okay? Thank you. Good. So when Walter saw her, she was 40.6 feet above the ground. He threw the pillow with an initial upward velocity of 40 feet per second. Okay, now first of all, that might seem unbelievable, but look how giant Walter is. He's almost as tall as the house, and he's even bending the roof a little bit, okay? And if you look at the pillow, it's almost the same size as the girl. So it's like a giant body pillow. So he is clearly the world's strongest man, throwing a giant pillow at the girl who's parachuting down, who's being a pansy. Okay? So are we good? Are we suspending our disbelief enough? Okay? All right. So here's the function. It even gives us the function, the equation for the path of the pillow. Okay? And we're saying very specifically x is the time, but very clearly again in seconds since the pillow's release. Now here's the best part. She missed it the first time. But then she caught it as it came back down. So we don't care that it might have gotten caught in the actual parachute or the little strings that hold up the parachute. No. We don't care about that. She just reached out, clearly. Okay? All right, so let's get on to the actual math and make sure we understand the math part, okay? What linear function can be used to find the parachutist's height in terms of x, which is the number of seconds since Walter threw the pillow? What you got? Linear function for the parachutist. Why is it negative 4.8x? Because she's decreasing, right? She's descending from the air. Parachutists don't rise from the ground, do they? Okay. So, is that it? Okay, we can start with negative 4.8x. I'm okay with that. But what else do we know about her? Yeah, we know that she was 40.6 feet above the ground when this whole thing started, right? So plus 40.6. Now, in order for it to be a linear function or an equation at this point, it has to have an equals, right? Now, last period when I did this, I wrote y equals. But then I looked back up at the problem that they gave us, the equation that they gave us, and realized that may not be the best plan. Because this one is already in terms of h, because it's representing height, right? So I should probably have this one also be h equals. Now, would that matter in the end? No, because we could probably figure things out. This might make it a little bit easier for us here, okay? Now, number 2, treat these two functions as a system and solve it. How do you wish to do that? We could do graphing. We could do substitution. We could set them equal to each other and solve. I'm afraid too many of you did graphing yesterday, so let's go ahead and do the math today so we can make sure that we're good on the math. Okay? So negative 16x squared plus 40x plus 15 equals negative 4.8x plus 40.6. What did I do? You got it? Oh, okay. I thought you were correcting me. I mess up sometimes. I'm a human. Yes, I am. If you don't believe that, I will destroy you. Not really. Destroy humans. Okay, ready? What kind of equation is this? Quadratic, so I need to get it equal to 0. Very good. Okay, so let's add 4.8x to both sides. And let's subtract 40.6 from both sides. Negative 16x squared. 44.8x minus 25.6. Sorry about that. 25.6. Perfect. Equals 0. How are we going to solve this? Probably quadratic formula? Because, I mean, our other choice is factoring. Probably not a great plan, right? Okay. I know that's not the only two choices. It's just the ones we've talked about recently. Okay. X equals negative b plus or minus the square root b squared minus 4ac over 2a. Alright, so I just put that directly into my calculator and trying to simplify it all, because we're not trying to see anything else other than the answers. So I did negative 44.8 plus all of this stuff, and then again I did negative 44.8 minus all of this stuff to get my two answers. Does that make sense? So I got x equals 0.8 and x equals 2. Okay. Any questions? So is that it for that question? Why not? I have to find. I found the x value. I need to find the other one. In this case, the h. Right? Okay. So if x is 0.8, where am I plugging back into? So this one? This original equation? I mean, I could, right? But this one's simpler. So negative 4.8x, excuse me, negative 4.8 times 0.8 plus 40.6 equals? Negative 4.8 times 2 plus 40.6? What do these intersection points mean in the context of the problem? So can we go look at the drawing of the giant man again? Tell me what we're talking about. Where? Where are we talking about? So first one is right here. And what is the time at that point? 0.8 seconds. And what value goes along with 0.8? 36.76? What does that mean? That's the height. That's the distance from the ground. This is 36.76. What is it? Meters? Feet. Excuse me. What else do we know? So right here, right? This is 2 seconds. This is 31 feet. Okay? Now I know it asks us that down in number 2, but it's no problem for us to explain it in the drawing. That's fine with me. You could also write sentences if you want. At 0.8 seconds, the pillow is 36.76 feet off the ground. And at 2 seconds, the pillow is 31 feet off the ground. Okay? How much time transpired between when the parachutist missed the pillow as it went up and when she caught the pillow on its way down? Because you said 2 seconds when she caught it and 0.8 seconds where she had missed it. I got 1.2 seconds, right? Okay. How much time did the parachutist have to adjust the pillow between when she caught it and when she touched the ground? What do you want to do for h? Why would we make h equal to 0? That's the height off the ground when she touches the ground, right? Okay, so which equation am I making equal to 0? Are we talking about the pillow or are we talking about the person? Okay, I know that the person has the pillow now, but she caught it, so there's no more parabola, is there? So we're talking about the linear function, negative 4.8x plus 40.6 equals 0. So we can add 4.8x to both sides, or we can subtract 40.6 from both sides. At this point, it doesn't matter. And then divide both sides by 4.8. What is 40.6 divided by 4.8? 8.46. No, that's fine. 8.46 seconds. So it was 8.46 seconds when she caught it and touched the ground. So how much time did she have to adjust it? From the whole time that Walter threw the pillow to the time she hit the ground was 8.46 seconds. Right? We would have to subtract the seconds. Which seconds? When did she catch the pillow? 2 seconds. So Walter went outside, threw the pillow at 0 seconds, right? 2 seconds is when she caught it. 8.4 seconds is when she hit the ground. Softly, we hope, with the pillow. But how many seconds did she have to adjust the pillow? 8.46 minus 2 would be 6.46 seconds. It is a giant pillow. Okay? Any questions about this? You see why I enjoy this problem so much? It's rather silly. It is so realistic, I know. Okay? All right, look at this real fast. I honestly think that if I gave you this worksheet, you could totally do it by yourself. I'm about 94% confident. Okay? I just doubt myself sometimes. Okay? Why do you think I'm so confident that you could do this worksheet by yourself? You've already done something like it before. You've done something like, here's a system of linear inequalities, graph them and shade. And then I've said, here's some quadratic inequalities, graph it and shade. And then I've said, here, I don't know what all I've said, right? But I've never said something exactly like this where you have a parabola and a line together, right? So some more nonlinear systems because they're not all linear. But how would it be different? It wouldn't, right? Okay, so a couple days ago when we worked on that worksheet where we had to graph stuff, how careful were we with our graphs? Not at all, right? I kept saying it's close-ish or here-ish, things like that. Can you tell how careful we're going to be with our graphs this time? Super careful, right? In fact, we're given tables. We want to plot these exact points onto our graph. So let's complete these tables. For me, this one's way easier to complete because it's just linear. So if x is -1, -1 plus 3 is 2. 0 plus 3 is 3. 1 plus 3 is 4. 2 plus 3 is 5. 3 plus 3 is 6. For this one, I'd probably be likely to just put that equation in my calculator and look at the table. Would you do that or no? Let's see. This one's probably easy. 0 plus 0 minus 6, so that's -6. 1 plus 1 is 2, minus 6 is -4. 4 plus 2 is 6, minus 6 is 0. So, can I show you a shortcut real quick? I already know these two without having to do any math. Do you know how? The properties of parabolas, that parabolas are symmetric, right? So shouldn't this be -4 and -6? Because I see where the zeros are, and I can go in that way. Okay, just remember stuff like that, right? I don't want you to have to work harder than you need to. It's always good to check it anyways, right? Okay. So that's 1 minus 1 is 0 minus 6, -6. Sure enough, it was right. Okay. 4 minus 2 is 2, minus 6 is -4. Sure enough, it's right. Okay. So let's go ahead and plot these values on this graph over here. -4, 6. -3, 0. -2, -4. -1, -6. 0, -6. 1, -4. And 2, 0. Ooh, I almost started graphing it. I almost started drawing the shape. Am I allowed to draw the shape? Yes, but what should I think of before I draw the shape? In this case, a parabola. Is it dotted or solid? You remember that? So yes, in this case it is solid. In this case, both of them are solid, aren't they? Okay. So just when I graph it, I want to be careful to know if I'm drawing a solid line or a dotted line. Is the main thing. Now before I go on, watch up here real quick, please. Before I go on, I want to go ahead and decide where I'm going to shade for this problem so I don't have to do that later. Okay? So how am I going to decide if I'm shading inside of the parabola or outside of the parabola? I could pick a point, right? Which one's the easiest to pick? When can I not pick 0, 0? When it's on the shape already, right? Okay. So if I can pick it for here. If I plug that in, 0 and for x and 0 for y, I get 0 is greater than or equal to -6. Is 0 greater than or equal to -6? So this is in the true part. So I shade toward the true, right? So in this case, I'm going to shade inside of the parabola. But I'm not actually shading yet. I only want to shade when I know the whole answer. Okay? -3, 0, -1, 2. Whoops. -2, -1, -1, 2. 0, 3. 1, 4. 2, 5. 3, 6. Again, this is a solid line. Am I shading above or below the line? If I choose this point, 0, 0, 0 is less than or equal to 3. Is 0 less than or equal to 3? Yes, so I shade toward the true points. I don't have any more graphs to graph, so I know where my shaded area is, don't I? Again, please don't get too OCD on me here. Just shade in the area. Okay? Any questions? All right, you have 2, 3, and 4 to do before you come to class tomorrow. 2, 3, and 4, the rest of them. Okay? Any questions? We good? Have a great day.